Okay, so I just want to spend a little bit of extra effort to talk about the capital asset pricing model and beta, and both what beta should represent and how beta is actually calculated, even though we won't do any actual calculations of beta. Okay, so let's start by looking at the capital asset pricing model. And the capital asset pricing model says that the expected return for any stock, and we're talking about UPS, so let's say the expected return for UPS is equal to the risk-free rate plus the beta for UPS times the expected return on the market minus the risk-free rate. Right? Where this term right here, this is what's called the market risk premium. Okay, so you may have heard that term before, and I'm kind of bad about using that term interchangeably with actually saying the expected return on the market minus the risk-free rate. So first is, this describes the general risk that the market associates with UPS, right? So we have some baseline level of return that's described by the risk-free rate. So we get some money for bearing risk-free assets, and that's just based on the time value of money, right? The risk-free rate is only exists because I should get some compensation, some return for parting with my money for however long that investment lasts. And then this describes the excess risk faced by the market, the average risk in the market minus the risk-free rate. So this is the market risk premium. This is the return given to the average asset in the market above what the risk-free rate is. And what beta tells me is, for any individual asset, beta tells me the relationship between the systematic risk that exists in the market, the average risk in the market, and the unique risk that it only exists for UPS. Right? So beta is UPS's relationship with systematic risk. When we think about this as how much should the expected return of UPS vary with the average market return, right? And so this might make talking about how beta is actually calculated might help to make it a little more clear, right? And so to do that, let's draw a little graph here, right? Okay, so on the x-axis here, I am going to write UPS's return in a given month. And on the y-axis, I'm going to write the market return, so the average return on the US stock market in a given month. I'm going to be a little bit hand wavy here, so we're not going to make our graph super accurate. We'll say this is positive 5% average market return, positive 10% average market return, negative 5 and negative 10%. And then for UPS, positive 5 and positive 10% return, and negative 5 and negative 10% return. Good. Now what we want to do here to understand the relationship between UPS and the UPS return on the stock price return and the average market return on prices is we're going to graph a series of different points, and those points are going to be months. So for instance, I'll say in January of 2000, let me pick 2010 so that these are more reasonable years. So in January of 2010, the market return, the average market price return was 10%, and UPS's price return was 5%. So I'm going to make that a coordinate, right? Where the x is UPS return, 5, and the y is the market return. So I'm going to graph that. UPS return 5%, The market had a 10% return, so that is January 2010. And then we'll say in February 2010, right, the market had a 9% return, UPS had an 6% return, and so we have 6 and 9, and now we can do this. And again, my graphing skills are not great. February 2010. Right. And so we just keep working our way through the months. We want about 60 months here to get a good idea of the relationship. So, in any given year, we might have, say, 0% market return, or any given month, 0% market return, 5% UPS. And then we might have, over here in the negatives. And, if we were graphing, the current month, we'd be down here, and so we're going to put 60 different plot lines here. And each one of these points represents a month, and the coordinates of that month are UPS's return against the average market return. Okay. Now, what we want to do is look at this graph, this series of plots, and try to understand if there's any relationship that can help us understand whether these two things move together. In other words, if the market return is high, is UPS's return also high? If the market return is high, is UPS's return low? Right? Is there any kind of relationship that can help us predict how these two things should move together? And what we can see here is that in general, hopefully you guys can see this, in general it seems to have an upward sloping trajectory. Right? If I was to say circle this, right? Maybe that makes it more clear. Right? Most of the points that I've plotted follow this slightly upward sloping trajectory. And that would imply a positive relationship, meaning if the UPS return is high, the market return is high. And if UPS return is low, the market return is low, and vice versa. Right? Now, the way we estimate this relationship is through a mathematical model. But what we do is we describe this as what's called the best fit line. In other words, I'm going to try and draw a line that best fits the relationship described, right? And pretend that's a nice straight line and that I'm a really good artist, right? And so this line should show the trajectory of these points in general, right? It's not about how many dots I can connect, rather if we go really deep, it's the line that I can draw that is the closest to every point on the graph, right? That's what the best fit line means. And we don't have to talk about the math of how we actually describe that. But once I've established what this line is, I can say that, right? I know that I can describe any line by a simple formula that hopefully you guys are pretty familiar with, and hopefully you learned back in grade school. This is the formula for a line. Y equals mx plus b, where m is the slope of the line, b is the y-intercept of the line, and then x and y are a series of x and y coordinates describing the points on the line. Right? Now, once I have determined this line, what I'm really interested in is the slope. This is my beta. Right? So calculating beta is merely a mathematical process of determining the line that best fits the relationship, right? And this looks to be a positive relationship. So here our slope is going to be 1. And remember what slope is. Remember that slope is the rise over the run, right? So if the rise here is, let's call that 2.5%, and the run, my math could be better, let's call that 1.5%, right? Then the slope is 2.5 divided by 1.5. Which is 1.6667. So this is our beta. This would be the beta for UPS, right? And again, it's all hand wavy. We would do the math correctly so that we would get this exactly. Okay, so we have calculated our beta. Our beta tells us the relationship between the UPS stock return and the average stock return in the market. Average stock return in the market. Looks to be a positive relationship, and we draw our best fit line. We use the regression mathematics to draw our best fit line. Again, this is all that somebody says we use regression analysis. This is exactly what regression analysis is. We calculate the slope of that regression line, and we get 1.667, and that becomes our beta. Now, what does this beta mean, right? How do I interpret beta? I interpret beta like this, right? I say if, all right, let me put, for a beta of 1.667, right? If the expected return on the market goes up by 10%, then